In this video, we have been given this exponential equation x to the power of y equaling to y to the power of x, and we shall have to find the values of x and y. How can we solve such an exponential equation? First of all, let's let y to be equal to kx, where k is a constant. And since this is an open question, we need to make some assumptions. The first assumption we shall make is that k cannot be equal to 1. And the second assumption will be that x cannot be equal to 0. So now, using these assumptions, let's see how we can solve this equation. If we put in y equals to kx, we shall have x raised to the power of kx, and this will be equal to y, which is kx raised to the power of x. And at this point, what we need to do is raise both sides to the power of 1 over x. So on the left hand side, we shall have x raised to the power of kx, and then raised to the power of 1 over x. And this will be equal to, on the right hand side, we shall have kx raised to the power of x, and then raised to the power of 1 over x. Now this x will cancel with that, and also this x will cancel with that. And therefore, we shall remain with x raised to the power of k, and this will be equal to kx. And now at this point, what should we do? In order to isolate k, let's divide both sides by x. This x will cancel with that. And so we shall have x raised to the power of k, and then divided by x, equaling to k. Now this x has a power of 1. And from the rules of exponents, whenever you have, let's say, a raised to the power of m divided by a raised to the power of n, this is the same as a raised to the power of m minus n. So this will become x raised to the power of k minus 1 equaling to k. And now let's make x the subject. So we shall have x to the power of k minus 1, and then we shall raise this to the power of 1 divided by k minus 1 equaling to, also we shall raise the right hand side to the power of 1 divided by k minus 1. Now this k minus 1 will cancel with that, and so we shall remain with x equaling to k raised to the power of 1 divided by k minus 1, and that's the value of x. And if you remember, we had set y to be equal to kx. Therefore y will be equal to k and then times k raised to the power of 1 divided by k minus 1. And this k has a power of 1. Now from the rules of exponents, whenever you have, let's say, a raised to the power of m times a raised to the power of n, this is equal to a raised to the power of m plus n. This means that y will be equal to k raised to the power of 1 plus 1 divided by k minus 1. Now let's see how we can simplify this. 1 and then plus 1 divided by k minus 1 is the same as, now 1 can be written as k minus 1 divided by k minus 1, and then plus 1 divided by k minus 1. And since we have the same denominator, we can combine the numerators. So this will become k minus 1 and then plus 1 divided by k minus 1. This will cancel with that. And so we shall remain with k divided by k minus 1. Therefore, y will be equal to k raised to the power of k divided by k minus 1. Now let's put in some values and see if we can find the values of x and y. Remember that we had made an assumption that k cannot be equal to 1. So if we let k to be equal to 2, then y will be equal to 2 raised to the power of 2 divided by 2 minus 1. And so y will be equal to 2 raised to the power of 2 divided by 1. And this will be equal to 4. And we had found x to be equal to k raised to the power of 1 divided by k minus 1. If we put in k equals to 2, we shall have x equaling to 2 raised to the power of 1 divided by 2 minus 1. And so x will be equal to 2 raised to the power of 1 divided by 1. And so x will be equal to 2. And if you want, you can prove these answers. Our equation was x raised to the power of y equaling to y raised to the power of x. If we put in the values of x and y, we shall have 2 raised to the power of 4 equaling to y, which is 4 raised to the power of 2. 2 raised to the power of 4 is 16 equaling to 4 raised to the power of 2, which is also 16. Therefore, the values of x and y are correct. So that's how you can solve such an equation. If you have found this video helpful, don't forget to like it and also subscribe to my channel. Thank you for watching and have a nice day.